I want to illustrate the method of using decomposition by function to help you in exploration. I want to do it by using the ice cream scoop example, and you may recall from the problem definition video that we came up with the problem statement: in what way might we create a better handheld tool for forming balls of ice cream from a bulk container? Now, decomposition by function is facilitated by the creation of what I call a function diagram. And a function diagram is basically a flow chart that describes what it is that the artifact has to do and can be thought of as functions involving the flow of materials, energy, and signal. And so let me just illustrate with the ice cream scoop. I think the flow of material is the most straightforward. So let's imagine we have the bulk container, which has the ice cream, and then we have a can imagine dividing some element of that, some portion of that bulk, and then we could imagine forming that portion into a ball. And so the first, if you want to think about it functionally, the first thing that happens here is an ice cream scoop divides from bulk so it takes the bulk ice cream and it divides it from the bulk. And then the second thing you might imagine an ice cream scoop doing is forming a ball. And so the flow of materials in this case can be thought of as two steps: dividing from bulk and forming a ball. And in terms of flow of material, that's what an ice cream scoop does. Now there's also a flow of energy, and the main energy flow in an ice cream scoop is apply human power or human force. You can think about that as a flow of energy from our user. And there might even be some signal, but there isn't always a signal flow. You might imagine some kind of signal, which is, is it a nice portion? And that flow goes back to the user. All right, so let me first emphasize that function diagrams are not unique. That is, there are many possible ways of decomposing what it is an artifact does by function. This is a reasonable way to do it. I think it's very useful to think, for most artifacts, to think about the flow of material, the flow of energy or force, and the flow of signal. And that lets you think about what are the elements, the fundamental elements of function that device performs. Now this is a very simple artifact, an ice cream scoop, but even for a very simple artifact, it is possible to decompose or break down what it is that artifact does into smaller pieces. The next step in using a function diagram, so this thing we call a function diagram, and the next step in actually using the function diagram for exploration is to pick typically at most 2 or 3 of these functions to use as a way to focus your exploration effort. And as I look at this, I think really the obvious ones are clearly the way in which the scoop divides from bulk is going to be critical. It's going to be critical to think about the application of human power, and maybe there's some interesting things that could be done as a result of focusing on the forming of the ball. But I think for now, I'm going to focus on these two, the application of human power and the dividing of a portion of ice cream from bulk. All right, so let me show you how that works. So we're going to divide our design problem into just two pieces, and the pieces are going to be divide from bulk and apply human power. And remember, the key idea in decomposition is we're going to focus single-mindedly on that subproblem and not necessarily in the context of the overall design problem we're trying to solve. So for instance, let me just give some examples for how we might how we might use that decomposition by focusing on applying human power. So some ways that you might apply human power: you might imagine twisting. You might imagine squeezing. You might imagine hammering or impacting. Let's just draw a little hammer here. You might imagine, I don't know, pushing. You might imagine pulling. Look at the little handle here. You might imagine, I don't know, let's imagine even, as crazy as this might seem, stepping on something. We might imagine, and I guess it's a version of squeezing, but I'm thinking about like the shears that are used in cutting branches that look like something like that. And that's kind of a squeeze as well. All right, now see what we just did there. We generated a bunch of ideas for how it is that human power can be applied. None of these in the context of ice cream scoops, but just generally, how is it that human power is applied? And you know, to illustrate that it really should be outside of the context of ice cream scoops. You can even imagine, you know, pedaling, right? It might be an application of human power. So those are all the ways you might apply human power, many of the ways you might apply human power. Okay, so now let's do the same thing over dividing from bulk. What are ways that things are divided from bulk? I don't know, you might imagine a bulk sheet of material and imagine that it's perforated and so I'm going to call that pre-divided and break maybe. Actually, breaking generally is an idea. Breaking, or I suppose let's see how we're going to break this out. imagine, let's see, oh, I like, how about this? How about punch? Punch. Um, there are certainly, what about just cut? You might imagine a cutter of some kind. Yeah, you get the idea. Let's imagine there could be, oh, how about like the way you think about the way an excavator works. An excavator shovel has a claw on it, and, and a big arm and an actuator, and we could call that excavator. Scoop. And let's see, how about carve or shave?